Welcome again, everyone, to Coding for All. This time around, we will be looking at Python data types. When we talk about Python data types has more to do with a data with common properties. So any data with a common property can be assumed to be a data type. And in Python, we have data types like the numbers, lists, strings, tuples, dictionaries, and sets. So we'll be looking at these few data types. So we'll start with numbers. When we talk about numbers, Python numbers has more to do with integers, floating numbers, and complex numbers. So for example, when I come here, we have a is equal to 5, and then we have a is equal to 2.0, and then we have a is equal to 1 plus 2j. Now a is equal to 5. What do you think 5 would be? What do you think the 2.0 would be? And what do you think the 1.1 plus 2j would be? So let's see. So we have our values over here. We have the 5 being an int, talking of integer. We have the 2.0 being a float. And then we have the 1 plus 2j being a complex number. So under numbers, we have integers, we have the floating numbers, and then we have the complex number data types. Right. So this is just about Python data types with numbers. Then the next thing we'd like to look at the Python list. Now, for us to know whether we are looking at a list or not, one key significant thing to look at when we come to Python list is the fixed brackets. So for example, anytime you see a is equal to this is a list. Now this is an empty list. So wherever you see anything like this, the first thing that should come into your mind is a list, right? There are times when we have this, then we are talking of a dictionary, but with time you will get more into it and you'll be able to distinguish between when we are assigning a value to a dictionary and we need to use the fixed brackets, and when we are talking of list. So with this we are talking about an empty list, right? Okay, so when we come here, we have a is equal to 1, then 2.2, then Python. This is a list. Now this list is filled with different data types because we have a number, an integer over here, we have a floating number over here, and then we have what we call a string over here, right? Okay, so this is a list. Now if we should print this list, we'll do print a, right? So let's just print that a. Okay, let's print this. Oh, sorry. Right. So we have our list string over here, and then we have the class type being a list, right? So this is just to do with lists. Lists are indicated with the fixed brackets over here, fixed brackets, block brackets over here. That's how we know we are dealing with lists. And there are some operations that we can do with lists, like slicing, where we can slice the list. So we can do a and do this and say it should give us from 0 to 1, right? It should give us from 0 to 1. Let's see. So we have to print this. So from 0 to 1, we have 1 over here. Let's say from 0 to 2. So this is 0 and then this is 1, right? So anytime you're dealing with lists has something we call indexing, and indexing always starts from 0. So if the indexing starts from 0, we'll start counting from 0. So here is position 0, here is position 1, and then here is position 2. So, and with Python lists also, whenever we are indexing, we get the last value and then we do -1 to be able to get where actually the value should end. So you realize I said it should give me from 0 to 1 the first time, and then it gave me only 1, meaning that it will move from 0 and then to go to 1. When it gets to 1, 1 minus 1 will give you what? 0, meaning it should give me only 0. Here I said it should move from 0 to 2. So what happens is that it will move from 0, 1, then it will come to the 2, right? When it gets to the 2, it will subtract, we'll have 2 minus the last value being, we'll have 2 minus 1. So it is always the last value minus 1 to be able to get the exact value where the indexing should end. Right, but we would go into indexing later on, and as we move on further, but just a little with the Python lists. Then the next thing we'd like to look at a tuple. When we say a tuple, what is a tuple? So a tuple is an ordered sequence of items, same as a list. But the only difference between a list and a tuple is that tuples are immutable and tuples are created once and they cannot be modified. What do we mean by that? So I said, what are tuples? Tuples are almost same as lists, but tuples are immutable. Tuples cannot be changed, right? So let's do this. Sorry. Let's say we have, oh, sorry. Let's do it. Another thing about tuples is that even though tuples are somehow similar to lists, the difference between the two, another difference between a tuple and the list is that tuples come with these brackets, while lists come with fixed brackets. Tuples come with the normal brackets, whereby lists come with the fixed brackets. So we have 5 program and then a complex number, and then we can see that this is a list, right? This is somewhat like a list, but the only difference between this and list is that this is fixed and cannot be changed, but lists have the opportunity to, you have the opportunity with lists for you to be able to modify them, right? Okay, so let's try and do something and see whether it will work. Let's try to do what we did with the list and see what output we would possibly get. So let's print T, right? Then it's of type T. Then let's see. Now we have T over here. T is equal to 5 program, and then T is of type tuple. Let's look at something else. Let's see whether we have the opportunity to be able to index tuple. So let's do right. So we have the opportunity to also index tuples, and it has the same rules as a list has when it comes to indexing, starting from 0, and then wherever your last value ends, which is stated over here as 2, you do the last value 2 minus a constant 1. So assuming you want the values within 0 to 15, then your last value should be, the last position of your value should be 14, because you will be doing 15 minus 1, which is equal to 14, so you should end at position 14. If we want 10 items, then it means we'll start from 0 and then count to 10, then minus 1, so our position value should end at 9. That is dealing with indexing. Great. So the next thing we'd like to look at is Python strings. When we talk about strings, we are just talking about any sentence or word that is within an inverted comma, that is within a quote, right? Any word at all that is within a quote. So we can have something like this. Let me comment this over here and then come down here. Now I have S is equal to, this is a string, anytime you see this, anything like this, it is a string. Why? Because this sentence, right, is within a quote. So strings are just values or variables that are being quoted. Assuming I have a digit over here, once I place a digit in here, right, once I do this, the two ceases to be a digit and it now becomes a string because it is within a quote. Now let's move back and then let's print them and see. So this is a string, and then we have s is equal to a multi-line string. This is also a multi-line string, and usually when we want to differentiate between the multi-lines, we weren't able to go through multi-lines within our earlier episode of coding for all. But when we talk about multi-lines, and multi-lines are designated or indicated with these three quotes over here. Anytime you see three quotes, we are dealing with multi-lines where you can write in multiple lines, right? Great. So this is just to do with strings, and there are other methods that we can do with strings. Let's see if we can do something with strings. So let's see, we have this string over here, and then we want to change all to a lowercase. I think we can do string.lower and then command B. So now we have all our strings coming in a lowercase. If we want them to be in an uppercase, all we have to do is change it to upper and then run this command. So this is just a method that we can run on strings. There are other methods that we can do with strings, but this is just a little something. But once we move on further, you have the opportunity to be able to try your hands on all the other kinds of methods that we have with strings, and also the other data types in Python. Then the last but one thing we'll be looking at is set. Then after we'll be looking at the Python dictionaries. When we talk about set, a set is an unordered collection of unique items, right? A set is an unordered collection of unique items. A set is what? An unordered collection of unique items. So an example of a set is anytime you want to know whether you are dealing with a set comes with curly brackets. Sets are designated with or indicated by curly brackets. So whenever you see A is equal to 5, 2, 3, 1, 4, this is a set. The reason why this is a set and it is not a list, neither is it a tuple, is because of the curly brackets over here. And you realize it is almost like a list, but it comes with a curly brackets, making it a set. Right. So let's try and print the type, and let's see what we will have. When we print this, we have the type being equal to set, right? So anytime you want to get a particular variables type or a particular data type, all you have to do is call type and then enter the value or the variable that contains the value into the type, and then you have the type, the data type of the value. Okay, now let's move on. So let's try and see if should we also attempt to do the same indexing that we did earlier on the tuples and the list, whether it's going to work with the what's the name with the set also. So what did we do? We printed A, right? Let's do this. So we'll have, now let's print. We have an error, right? A set object is not subscriptable. In other words, what it's trying to say is that we are not able to index a set because it's a set. We are not able to index a set. Now, assuming we would want to, okay, when we are done, then we get there. Just in order not to confuse you, let's look at dictionaries. Now, anytime we want to also know whether we are dealing with dictionaries or not, dictionaries are key value pairs. A dictionary is designated with a key, and has a value whereby when you call the key, the value should show up. So a dictionary is also an unordered collection of key value pairs. A dictionary is an unordered collection of key value pairs. So let's do this. Let's comment this first. Then let's come down here. Sorry. So, right. So the reason why this is a dictionary and this is not a set is we are having an unordered collection of a set of items, but you realize that we have these signs in there. We have columns in there. So look at where the comma is. There are a key value pair here, then followed by a comma, then a key value pair. So anytime you see key value pairs within a curly bracket, we are dealing with lists, right? And anytime you see something, assuming there was D is equal to this, this is an empty dictionary. So we are dealing with dictionaries over here now. So let's print one and see what will happen. Let's print one. Oh, sorry, dictionary. So for us to be able to get any value at all within the dictionary, what we are supposed to do is we are supposed to call the key and then the value will show, right? We call the key and then the value will show. And with key value pairs, anytime you want to know the difference between the key and the value on the left hand side is the key and the value at the right hand side is the value. So this is the key and then this is the value being separated by a column. So what we have to do is we have to have this over here and then have this over there, right? Then when we print it, print one, this the value should show. Great. I omitted a D. I wasn't looking at the D. I was just looking at the values in here. So we had this dictionary, right? And then we had emptied everything in here into the D. So anytime we want to see these values, all we have to do is call the D, right? Now I'm saying call gets me the D, but I want only the key within the value D. So I call the D and I said it should give me the key within the value D. And the key within the value D, I specified 1 and they gave me the value, right? Say I need key over here. So all I'll need to do is get a key over here, bring it in here, right? When I print it, I should get a value 2. Now the difference between this key and this key is that this value over here is a digit. It is not a string, and this is a string within the dictionary. So in referencing them over here, I have to state the data types of these key values, of these keys. Here was 1, it wasn't within a string, but here was a key and it's within a string. Now assuming I was supposed to move this, I was supposed to state the key without the quote. What would happen is it would give me an error saying that key is undefined. Now let's try it. Key is not defined. The reason why key is not defined is that it is seeing this key as an object, right? Because seeing this key as an object and it's asking me why is this key over here, because the memory doesn't know this key, because this key is an object. It's being seen as a variable that should contain a value, but it is not being defined. That was why we used the string to be able to keep the state of the key as a string, right? So that Python will be able to understand what we want, then it will be able to give us the needed output, right? So these are just a few things you can do with Python data types. Now what we want to look at, assuming we want to change each of these data types or any of these data types into a different data type. So for example, we want to change an integer into a float, right? So the easiest thing we could do is we'll state the data type that we want to convert the value into, and then call brackets and then put the data inside. So for example, now my 5 over here is an integer, right? Now I said it should float it, meaning that it should change this 5, which is an integer, into a float. So for example, let's say is equal to this, so let's print a. Right, 5 is type integer. Now let's change this integer to a float. What do? We say a what should be floated. So the easiest thing to do is let us float a. Let's say float a. Right. Now let's print it. Now 5.0 is of type integer. Sorry. Let me just name this b, right? And state here to be b, and then here should be b. Then let's run it now. Now 5.0 is of type class b, right? Now I said b is equal to float a, meaning it should change the state of a, which is an integer, to a float now, and then we had this, right? Okay, now let's say we have a list and then we want to change the list to a set. So the easiest thing we could do, similar to this, we would have to call the set over the list. So we have to come here and then print this. So let's print this. Right. So now our list has turned into a set because we called the data type set and then we inputted the list into the set, changing the data type. Alright, so this is usually mostly for any type of data type you want to do, and this is just a little bit of data types and understanding data types in Python, and we'll be moving on next where our next episode looking at Python type conversions. So let's see you next time. Subscribe to this channel, Coding for All. Bye there.